Okay, so here are a couple of examples from 5.7. The first one I'm going to do is 398. 398 in 5.7 looks like this. Integral dx square root over 1 minus 16x squared. I will rewrite it a little better so that it looks like the difference of squares underneath. That's going to be the integral of dx over square root of 1 squared, if you will, minus 4x, the whole quantity squared. Okay, so what's happening here is we don't have just x, we have 4x. So we're going to do a substitution, and I'm going to do it explicitly first, and I'm going to show you how to do it implicitly later. The beginning is the same for both problems. I'm going to let u be equal to 4x. du is then 4dx, which means that dx is du over 4, if you will. Okay, so now making the substitution, what I get now is this is going to be equal to du over 4 square root of 1 minus u squared. Now what I'm going to do is I'm going to take the 4 out. I'm going to get 1/4 the integral of du 1 minus u squared. Well, now what's going to happen here is it looks just like our formula, our first formula. So what we're going to get is 1/4 sine inverse of u plus c, right? And so going back, we're going to get 1/4 sine inverse, and what we have is 4x plus c. And there's your final answer. I would have done it a little differently. I would have done an implicit substitution, that is, doing it in my head. And what it would have looked like is this. So I have this so far. I know that if I let u be 4x, du is going to be 4dx. So what I need is a 4 here. If I need a 4 there, I need a 1/4 out here. Okay. So essentially, now I know that it's going to be 1/4 the integral of 4dx, which is what I needed, over square root of 1 minus 4x squared. That's simply going to be 1/4 sine inverse 4x over 1, but I don't have to write the 1, plus c, and I'm done. Looks a little cleaner, but the choice is entirely yours. The second example that I'm going to do is, let's see, what number is this one? I don't know, but it looks like this. From minus 6 to 6 of 9 over 9 plus x squared dx. Okay, I'm going to again rewrite it so that it looks like difference or sum of squares on the bottom. And what it looks like is minus 6 to 6 of, now we have 9 over 3 squared plus x squared dx. We can simply rewrite that as taking out the 9, so from minus 6 to 6 of dx over 3 squared plus x squared. Here we have x, we don't have 4x, we don't have a function of x, so dx suffices up there. And the formula that it looks like is the third formula. So what we end up with in this case is, let's see, we end up with 9 outside still, and inside we're going to have the tangent inverse of x over 3, and it's going to be from minus 6 to 6. You might be thinking, well, why didn't you need a c here? Why didn't you need that? Well, because to need the c, we needed to have an indefinite integral, because this is a definite integral. Whatever I pick for c is going to be canceling anyway, and I left out the 1/3 here. Okay? So we end up with 3 tangent inverse x over 3 from minus 6 to 6. That's going to give us 3 tangent inverse of 6 over 3 minus tangent inverse minus 6 over 3. So that simply gives us 3 tangent inverse of 2 minus tangent inverse of minus 2. Okay. It could be simplified a little more, but that suffices. Your assignment for this section is going to be 391 to 401 odd, and I also want you to do 423. Alright, so thank you for listening to this, and we'll do the second lecture in just a minute.